Okay, so let's look at some more uses of identities and trigonometry identities. So what I've got here um, are all of the identities, that you've learned so far. And just recently, we used these ones of cosine, sine, and tangent. Um, these ones actually for tangent and cotangent. We've also used some of these reciprocal identities. I think maybe once or twice we used a Pythagorean identity. And we just learned, about even and odd identities, but really haven't used them just yet. And we did learn also about cofunction identities, but if you remember, there's this other page where, here are the identities that we've looked at so far, and there are so many more. Okay, so why are there so many more identities? What good are they? What purpose do they serve? And so some uses of that's a spelling. I got to change that. Trig identities is number one. You can use them for simplifying expressions or in order to help you simplify an equation. So it can be difficult and sometimes impossible to work with trigonometric expressions as they're presented. So for example, we've got 1 minus cosine squared theta all over sine theta. Identities in general can be used to reduce an original expression to a new simpler one that is easier to work with. So for example, 1 minus cosine squared theta, we can use the identity, this Pythagorean identity, and 1 minus cosine squared actually is equal to sine squared theta. And so you've got sine squared theta all over sine theta, and one of these cancels with one of those, and this is what you get. So you started with this, which you couldn't really do anything with. You couldn't simplify that anymore, but we could convert the numerator into a different expression that then allowed us to perform a simplification and reduce it down to that. Okay, so one of the uses of trigonometric identities is for the purposes of simplifying expressions. Another use is with equivalent conversions. So we might have a trig expression like this one, which is the cosine of theta with another radian angle. And, maybe this would be difficult to work with, but we can use a trig identity that tells us that whenever you have the cosine of two angles being added together, you can rewrite it in this form. So instead of having two angles present, now you just have one angle. And the third use is for proving and disproving other identities. So where do you think the identities presented thus far came from? The answer, a proof was completed to validate the equivalence of two expressions. Using the formal rules of proving and disproving a mathematical claim, when a mathematical claim has been evidentially demonstrated to be true, the claim becomes an identity that can be used in turn to validate or invalidate new mathematical claims. So for example, a problem you could have is prove that secant theta is equal to 1 over cosine theta. So you were just kind of told that these two are reciprocals of each other. All right, so how do we prove that this identity is true? And so we prove it by using previously established true identities. So for example, if we start with 1 over cosine theta, and we know that cosine theta is x over r. So we have a fraction of 1 over x divided by r. And now if we get this denominator fraction and move it up to the numerator by just flipping the fraction, then we get r over x. And r over x is the definition of secant theta. So we started with one side of this equality. We went through some mathematical equivalences using previously established mathematical properties, and we ended up on the other side of the equal sign. And so this proves that 1 over cosine theta is equal to secant theta. So those are basically the three uses that we're going to be using these trig identities for. And next we'll have some examples where we see, increasingly complex ones to figure out. But this is enough for now. All right. Let me know if you have any questions.